and we'll start from current slide. Okay, fantastic. Now, a few announcements, and they're pretty important, so listen up, folks. First and foremost, I think I've announced to you before, but let me repeat it in case anyone's here who wasn't here before when I announced it. They printed the final exam schedule, sent it out a couple weeks ago, or they published it, and I printed it. And it was a day or two, or a little bit after I printed, that I finally noticed they had it wrong, okay? They have the first day of finals as being Monday the 29th, and it's not supposed to be. It's supposed to be Tuesday the 30th, and goes through Monday, whatever that is, May 6th. That's supposed to be the last day of finals. Now, that doesn't affect this class any, but it may affect any other class you're in. So check with your instructors and see. I emailed the dean about it when I realized it. She didn't publish anything else. She may have responded, but I haven't seen the response. But basically, I talked with my boss, the associate dean, on Friday. He said, yeah, they realized she did it wrong, but rather than change it, she's leave it up to the instructor. Monday is supposed to be the last day of class, but since she published it this way, if they want to give a final that day, they can. So they don't let us do this, but I guess the administrator can do it. Okay, we're not supposed to change the final exam schedule, but they did. Okay, so anyway, for us, Thursday is the last day of class, which leads to all sorts of interesting things, and we'll get to that in a second. Well, I guess we'll get to it right now. Number one, let me ask you the question. Should have been asking it every day for the last few weeks. I can't remember if I even mentioned it in this class before. Have you done the student course evaluations? Yay or nay? Not yet, some have? Okay. Please do those. I know it's late in the term to be asking, but please do them. If you want to wait until after you've seen the final and see what it's like and stuff, you can do that. But just don't forget to do the student course evaluations. I've had a few students ask me, well, do I have to do the one on blah, blah, blah? Because usually they'll attach another one besides this course. They'll put something else out there, like maintenance or food service or registration or library or something like that. Please do those too. I get feedback from you every time we meet, even seeing the whites of your eyes or not, I get some sort of feedback, and, you ask me questions and stuff. Those other folks, they don't always get feedback from you because, who have you ever go to maintenance and say, hey, y'all are doing a good job or something like that? Probably most of us don't. So please do all the evaluations requested. Certainly the ones for us, because we really count on those, and then also the others. And this is a SACS year coming up, and SACS will be looking at those, and if they see very low percentages, the college could get gigged. I don't know how seriously, possibly seriously. So please do the student course evaluations. Okay. Now, about Thursday being the last day of class. That means that on Thursday, I'll be returning all your previous tests to you on Thursday. Or I'll put it this way, all I can get graded by then, since I just got in several handfuls of papers today, both from this class and the previous class, so I'm going to grade like crazy and try to get them all done. But I will get them all back to you. If not Thursday, then when you come and return in your thing. I'm going to try to have them done by Thursday. Okay, so that means you have to have them in before Thursday. And like I said, I received a whole bunch today. Now, this includes your research paper. Thursday's the last day to get that in without losing points. Now, I'll take it later, but you'll be losing points if it's after Thursday. So please get your research paper in. Several came in today, so thank you for those. I'll try to get those graded as well. But I'm going to focus on getting test graded first and then the research papers later, because I can't return research papers to you. Periodically, they ask for samples of student writing, so I have to hang on to those to show that we do require a writing skill. Okay, that's how I interpret mine. It's a communication skill. Okay, so those are two things to do with Thursday. Then also on Thursday, I'll be giving you your last test. there was an S on that, by the way. The test on Chapter 6, it'll be very short, not nearly as long as the first 3 tests have been, okay, 1 page, and pretty simple. And then the comprehensive final, which will also be a single page, very short. The 2 of them together probably not as time-consuming as any one test has been so far. So that's what he says anyway. But I think you'll find that's the case. Okay? So, any questions on how we wrap up the term? Then, when are they due? Are any of you graduating this term? 1. Okay. You have to have the last test and the final into me by Thursday if possible, because I have to have your grades in by Friday noon. Okay? Now, the rest of you that are not graduating anytime next week, including up to Monday of the following week. We'll accept it then. Technically, they're all due by Thursday, but I've got to have hers because she's graduating. But then the rest of you, if you get them to me by Thursday, fantastic. You'll see your grades sooner. And by the way, I hope you know this by now because you've been around the block a few times. Look for your grades. Once finals start, look for your grades on Blackboard, because they generally close students off the student suite once finals start. The reason for that is it's a very old system, a very antiquated system, a very weak system, and my goodness, what is this? It looks a lot like a guy I've seen before. Who is he? Okay. All right. So let me repeat a few of those because you may not listen to say. Thursday's the last day of class, which means the Thursday is when I return all your previous tests to you, which means I have to have them all in before Thursday. Today preferably, but tomorrow okay, but by the beginning of class on Thursday because I'm returning them all then. Research papers are due in by Thursday if you haven't already turned it in. And have you done the student course evaluation yet? Even know what that is. Okay. Okay. Please do the student course evaluation.
Is it on your email? Do they email?
They usually send an email. I don't know. I don't receive all student emails. They usually do. Did any of you receive an email about student course evaluation?
I think I
Right. And then you find that. There's a link. Click on that. And you go straight to it. Right. That's what they usually do. But I don't see all the student emails, so I don't know if that happened. But it did. Okay. So yeah, look on your email. Find student course evaluation. Click on the link. It takes you there. Please do them all, even the ones they ask about. Bookstore, or library, or anything like that. Okay. All right. And then on Thursday, I'll be giving to you. You'll be bringing to me anything you haven't turned in so far. I'll be giving back all the things that have been turned in up to then, except the research papers. I have to keep samples of student writing for that. But I'll be giving you the Chapter 6 test and the comprehensive final. Okay. So I'll be distributing those to you on Thursday. Okay. Now, I'm going to have to run off the test, Chapter 6 test, before we finish in Chapter 6 because we're having class on Thursday. So I'm going to guess how far we get. If we get that far, fine. If we don't get that far, I'll let you know. These questions are optional. Okay. So don't panic if you see something on there we haven't done yet. All right. Any questions? All right. Please do the student course evaluations. Let's get picking up where we left off. We're in Chapter 6, Additional Topics in Trigonometry, and we're in 6.3, Vectors in the Plane. We're pretty close to finishing Vectors in the Plane, and this is at the bottom of page 420 is where we are here. Here's the slide. We were talking about unit vectors, okay? There are several that are called the standard unit vectors. If we have, this is on the plane now, the xy plane, okay? The unit vector in the direction of the x-axis, its standard name is the I vector. Now that's a bold I, meaning it's a vector, and it has components 0, 1. 0 in the x direction, 1 in the x direction, 0 in the y direction. Its components are 1, 0. The j vector is going up the y-axis. its components are 0 on X and 1 on Y. So that's its unit vector, the standard unit vectors in the direction. If we were talking about space and you had a z-axis coming out this way, that would be vector k. The standard vector would be k, and it would be 0, 0, 1. This one would then be, if you were to talk about space, 1, 0, 0. This would be 0, 1, 0. And k would be 0, 0, 1. Okay, get to that later. This is on the plane, so these are our two standard unit vectors. Now again, when the book writes them, they write them in bold just like they do any vector. When I write them, I put a hat on them because I can't write in bold, so I put the hat on them indicating the unit vectors. Now, they say this, I hope this won't be confusing. Note that the lowercase I, if it's bold, it's a vector, so that's a unit vector in the positive x direction. Written in boldface to distinguish it from the imaginary unit, little I, and usually written in italics, no less, which is the square root of -1, which we're not dealing with now. So there shouldn't be any ambiguity here, but just don't get those two confused. The standard unit vector is always bolded, or I put a cap on it. The imaginary unit is usually written as lowercase, which this is too, not bolded, no caps, no anything else. It's just written as a little I, and it's written in a number, 3i or something like that. All right. Those vectors can be used to represent a vector v in a different way. Now, back when I was first learning about vectors, probably college, I can't remember we had them in high school, but when we did, this was how we referred to vectors in sort of standard form. Okay, and we even probably call it component form. Nowadays, they use the angle brackets, which are so much easier, shorter, more concise, and very clear. But what you can do is express this as the magnitude of V1, which V1 is just a magnitude. It's a component here. V1 times the unit vector in the positive x direction, V2 times the unit vector in the positive y direction, times that, and then that gives you V1i plus V2j. This is what we used to call component form. Nowadays they call it ij form or something. The scalars V1 and V2 are called the horizontal and vertical components of V1, whether they're written like this or written like this. They're the horizontal and vertical components. You know they're horizontal and vertical because they go with the horizontal unit vector and the vertical unit vector. So this is another way to write a vector in ij format. Okay, and if you're in 3-space, ijk. Anything beyond that, you basically use angle brackets. But we're not going to travel beyond that, okay? So this vector sum, V1 plus V2, is called the linear combination of the vectors I and j. So that's the name they give it now. Much more complicated sounding name. Any vector in the plane can be written as a linear combination of the standard unit vectors I and j. In 3-space, I, j, and k, okay? So the same components that showed up in angle brackets with commas between them, they are the components of your I, j, and k. So same letter, nothing new, it's just how you write it. As a linear combination with plus and minus sign, plus signs usually, or an angle bracket with commas in between. Same representation. Now, they're skipping example 6 and 7 before we get to direction angles. So let's back up. Okay, that looks like a good place to do it. Okay. Good deal, thank you. Are you through? No. Oh, okay. And when?
Thursday.
Huh?
Thursday.
Thursday. You're not going to do Wednesday tomorrow?
I don't think I can.
Okay. Okay. So Thursday. Okay. All right. We've done example 4. This will be example 6. Let me get my pen set up. Okay. Let U be the vector with the initial point 2, 5. So this is usually what we call P, 2, 5. That's a point because those are parentheses. Oh, it's 2, minus 5. Those are coordinates of a point with inside parentheses. And the terminal point, which you usually call Q, and this is at -1, 3. Again, these are coordinates of a point. You can tell that by the parentheses. Those enclose coordinates of a point. It says write U as a linear combination of the standard unit vectors I and j. So how would you proceed? And it's pretty simple, by the way. How would you proceed? Oh, and here's Stephanie. You are in. Oh, good deal. Thank you. Oh, I don't need this. Test or something. Glad to take those. Okay. All right. So, again, because we only have one more day, and I'm not guaranteed you'll hear this because you've been here in class. Thursday's the last day of class, okay, which means several things. Number one, well, let me say this before I forget this one. Have you done the student course evaluation?
I think I have 2 more left.
Okay, yeah, well, please do those. Okay, back to Thursday. Thursday is the day your research paper is due. I will accept it after Thursday, but you'll be losing points after Thursday. It's the last day to turn it in and not lose points, okay? Now, it's also when I return all of your tests that you've turned in so far, which means it's too late to turn in any test after the beginning of class on Thursday. So if you don't have all your tests, get them today and get them into me before class on Thursday, which includes I'll take them today, I'll take them tomorrow, or before class on Thursday, okay? Anything up until class time. Because at class time, I'm returning those. I cannot return your research papers because periodically they ask for samples of student writing. So there's that. Then also on Thursday, besides returning your papers to you, we will have class. But then at the end of class, I'll be giving you 2 tests. Your Chapter 6 test, which will be very short and, of course, very sweet. And then your final exam, comprehensive final exam, which will also be very short and very sweet. Okay. So, any questions? All right. So back to this one. We're on in Chapter 6, additional topics in trigonometry, 6.3, vectors in the plane, example 6, top of page 421. We're given that U is a vector with initial point 2, -5. That's what I've labeled as point P, and terminal point -1, 3, I labeled as Q. It says write U as a linear combination of the standard unit vectors I and j. How would you begin? You tell me. Any way you want to start, tell me. Anybody want to start? How would you get the vector U? Just because it's U, that does not imply it's a unit vector. It is not a unit vector. Okay. I and j are unit vectors, so I'll write those differently. How would you express U? So again? Okay. So, would you do it in angle brackets first or not? You would. Okay, I like that. Okay, now, it's always final minus initial. Terminal minus initial. Okay? So you start with the -1 because that's the terminal x. Then you subtract from that the 2, which is the initial x. Then put your comma. Do the same thing for the y's. What would that be? 3, what? Minus a -5, right? Always terminal minus initial. Difference, okay? So, what would this be? Your x component would be -3. Your y component would be? Is what? 8. Perfect. Okay. That's in what I call component notation. But they want it in linear combination of your unit vectors. So what would that be? real simple transformation, what would that be? Negative 3i plus 8j. Same components you use here, you just write them with the ij components there. All there is to it. So I like the idea of doing it in component notation. It's always the easiest to deal with. Just remember, it's always q minus p, terminal minus initial for both the x and the y coordinates. Get that down, then write it in. Yes?
What's the magnitude?
What's what?
Magnitude.
Magnitude? Okay, what's the magnitude of that vector or any magnitude? Any magnitude. It's the length of the vector. Okay, does that help?
So x and y.
Okay, no, x and y are directions. Okay. X and y are directions. I and j are unit vectors in those directions. Okay, meaning unit vector meaning a magnitude of 1 along the x-axis, a magnitude of 1 along the y-axis. Okay. Now, for instance, what would be the magnitude of that vector? This is vector u. I said it's not a unit vector, so don't be confusing u with unit vector. It's not. That's just a regular old vector. These are unit vectors. What would be the magnitude of that vector? Since you asked, let's do it. The magnitude of u would be what?
1.
I guarantee you it's not 1. Because what's the definition for magnitude? Square root of, it's Pythagorean theorem. Okay? You're going minus 3 on x plus 8 on y. What's the length of the vector described by that? It's what?
A squared plus b squared?
That's it. It's minus 3 squared plus 8 squared, and then take a square root of that. And that would be the square root of minus 3 squared is 9 plus 64, and that would be the square root of 73, which I'm pretty sure is a prime number. So I know it's not a perfect square. Something between 8 and 9. Okay? That's the magnitude of that. Definitely not a unit vector. Not 1. Okay? It's between 8 and 9. Definitely not 1. Okay? Does that answer your question? Magnitude is the length of the vector, and you get it by doing your x component, the y component, and do the vector that joins those two together, and that's the length of that vector. So,
that's not the magnitude.
huh?
You said that.
Okay. If this is your x, negative 3 this way, that's not it's going downhill. Positive 8 this way, then the vector that goes negative 3, 8, the length of that vector is square root of 73. The length of that, how long is that? Because you know, this is 3 units this way and 8 units this way, so it's got to be more than 1, okay? It's between 8 and 9 units that way. The direction would be in the direction, to the northwest, closer to the north. That's the direction up there. And here's Ariel. And I guess I need to repeat everything for her. She may or may not go back and listen to the beginning of class. So I'll try to do it quickly. Thursday's the last day of class. And before I get into that, have you done the student course evaluations yet? Not yet. Please do those. Okay. Thursday's the last day of class, which means several things. It's the day your research paper is due. If you don't get it in sooner. Sooner is better, okay? But get it in as soon as possible, but no later than Thursday. I will accept it after Thursday, but you start losing points after Thursday, okay? So please get it to me sooner rather than later, okay? Thursday's also the day I give you all the papers back that you've turned in so far. If I can get them all graded between now and then, because I got a whole stack in from my first class, and then I got another whole stack in from this class so far today. So please get me everything you can before Thursday so I can return it to you Thursday morning. If you turn it in Thursday morning, I'll have to give it to you whenever I can get it graded. Okay. And then I will be giving to you your Chapter 6 test and the final exam, the comprehensive final exam. I forgot to ask the last two people maybe that came in. I know that Patience is graduating this term. Anyone else graduating this? You're graduating this term? Ariel, are you? No. Okay. So for the two of you, you have to have your both tests back into me by Thursday of next week. I'll give them to you Thursday of this week. You have to have them back by Thursday of the following week. That's when everybody should have them in, but I can't accept the others as late as Monday. Because graduating students, I have to have your grades in by Friday noon. So I have to have your test by Thursday, okay, anytime Thursday. And then the rest of you, whenever you get it to me by Monday the following week, but anytime you get it to me, I have to have yours in by noon on Wednesday of that week, which is the May 8th, I think it is. So, and again, I'll say this, don't look for Student Suite to find your final grade. Go to Blackboard. If it's not in Blackboard, it's not going to be on the Student Suite because they usually close down Student Suite. I was starting to say this before the last person started coming in. I never got it said. They usually shut students out of Student Suite during finals week, and here's the reason. We have an antiquated system, and the last time that I remember hearing anything, there were only something like 8 or 16 portals access to the system. Okay? Most of the time, not that many people are on it at the same time. But during finals week, everybody gets on it and see what the grades are. Well, if students fill up those portals, and they're not many, I'm guessing maybe 16 or 32 now, but it's still precious few, that means the instructors can't get in to put your grades in because everybody's out there looking. And you just have to be very lucky to get someone right to say, sign off, get in. So they shut out students from that, and that way we can get the grades in. It's a terrible old system. That's what we have to live with. So look for your grades on Blackboard, because we always put them in Blackboard first and then put them in the suite. And you won't go see it in the suite anyway until after finals are over. So look in Blackboard first. Okay? At one point, I may even get the grades upgraded there now, but it's been a while since I've been able to put anything in Blackboard. Here's the situation with me right now. We're working on fall schedule right now, and it is a terrible mess, especially in math, because last fall we did all these new tutorial labs and stuff one way, and this fall we're doing them a totally different way, so I'm having to, 3 or 4 different ways we're doing them differently, so I'm having to change everything in fall schedule to match what we're doing this fall, and so far it's been a nightmare, but I'm making progress, but it's very slow progress. So that's why I haven't had time to put anything in Blackboard recently. Although I've been working on that. All right, that's it. Any more questions about this? Good question on magnitude. Got it? So there's example 6, and hopefully that's what they got in the book. They sure do. Good for them. Negative 3i plus 8j. Let's do example 7. Okay? Example 7. Let u equal, vector u equals negative 3i plus 8j. Hey, I've seen that before. The one we just found. Okay? And v, vector v is equal to 2i minus j. Okay? Find 2u minus 3v. 2u minus 3v. Okay? And I'll assume that since they gave them to you in linear combination form, that's how they want the answers. So what would you do? You have to be thinking while I'm getting this. Did you finish? Okay, you're coming back when? Huh? Tomorrow? Okay. Before 3:30? I mean, 4 o'clock. Okay. Okay. How would you proceed with this one? Okay. Okay. Let's just do exactly what it says. Let's do a 2 times u is, or u are, minus 3I plus 8j. Minus 3 times v is 2I minus j. Just plug them in, like Glade, right? Now, distribute. What would the first one be? Negative 6I. Continue. Plus 16j. Next. Minus 6I. Plus 3j. And now, sort of like combining like terms. Combine like components. Okay? So what you have? Negative 12I plus 19j. Done. Of course, you could have written this in component form, that in component form, and done the same thing in component form. That, about 6 of one, half dozen of the other. Just the fact of having to rewrite them is an extra step, whereas this one you can just do the steps that you got. Any questions on this? Do you see what we did, how we did it, why we did it? Make sense? Okay, in the book, oh, believe it or not, they changed it to component form, and they wrote their answer as negative 16. So I said you could do it. That's how the book did it. Negative 12, comma, 19, close bracket. They only did it up here. They wrote this one in component form, that one in component form, then did the combinations in component form, and then left the answer rather than going back to what it was. They're both right answers. However you get there, as long as all the steps you take are right, you should get the right answer. Okay? Any questions on that? And they said, oh, I'm sorry. No, they did it both ways. Sorry. They did it the way I did at the top, then they did the checkpoint, and then they converted it to this. So they did it both ways, and they got the same answers. All right, now we're ready. If there's no questions, let's go to direction angles. Okay, I've been sort of hem-hawing around this because we hadn't really gotten there yet. Okay, we've been talking mostly about magnitude, but very little about direction. So let's now, how do we express our directions of vectors? This time u is a unit vector. U is a unit vector such that theta is the angle measured counterclockwise from the positive x-axis to the vector u. So obviously we're in two space in the plane, xy plane, and so we're only moving in one direction, okay? Positive x-axis counterclockwise to where we find the unit vector u. Then the terminal point of u lies on the unit circle because the unit circle has radius 1. So wherever you are on that, you're 1 unit away from the origin. So that unit vector describes the unit circle there as you spin it around. And you have that u is equal to the component of x, component of y. Well, on the unit circle, since the hypotenuse, which is the magnitude of u, is always 1, then y is the sine theta will be opposite over hypotenuse, which is y over 1. Well, the sine theta will be, let's see how to say it. The sine of theta is opposite over hypotenuse. So hypotenuse, the magnitude is 1. So the opposite side y is equal to sine theta. Okay? Just turn that around, it's that. And the magnitude of x is, well, do it this way. cosine of theta is the magnitude here over the magnitude there. Well, that magnitude is 1. So cosine theta is equal to your x component. So, as long as you're dealing with the unit vector and unit circle, your x component is the cosine theta and y component is sine theta. Because what is the square root of sine squared theta plus cosine squared theta? What is sine squared theta plus cosine squared theta? 1! And the square root of 1 is 1. So sure enough, those are your components. So therefore, you can write the vector u, as long as it's a unit vector, you can write the unit vector as cosine theta, comma sine theta. Or cosine theta I plus sine theta j. As long as u is a unit vector, that's always going to be the case. Always. So there's your angle theta. Okay? That angle theta is called the direction angle of that vector u. Okay? Direction angle of that vector u. Okay. Because the magnitude of u is 1. Okay, suppose that u is a unit vector with direction angle theta. If v is some angle, is some vector, not necessarily a unit vector, ai plus bj. And that can be any vector that makes the same angle theta with the positive x-axis, then it has the same direction as you did. It does. Okay. So, and you can write that the magnitude of the vector v is, this is the unit vector u, that's the magnitude of 1 in the direction, okay, I'm sorry. It's a unit vector with a direction of theta, so does v, it has an angle theta. Okay, so that's the direction part, here's the magnitude part. So together, they give the magnitude and the direction of that angle v, that vector v. So you could write it this way if you wanted to. Magnitude of v cosine theta I plus magnitude of v sine theta j. In other words, if you know the angle and you know the magnitude, you can write the components of the vector. It's always going to be that way. Always. All right. Because vector v, ai plus bj, is this, v cosine theta, magnitude of v cosine theta I, magnitude of v sine theta j, it follows that the direction angle theta for v is determined from the tangent of theta, which is sine of theta over cosine of theta. Okay? Well, if we multiply numerator and denominator by magnitude of v, we found out this is your v and that's your a from here and here. Okay? So therefore, the tangent theta is always the vertical component divided by the horizontal component. So now you don't have to know the angle itself. You can know this is how you get the angle. Tangent theta is equal to b over a. Whatever your vertical component is divided by the horizontal component. And did you have to go through all this? No, you could have just done that using any old angle v here, any old vector v here. Then you know that the y component divided by the x component, that's going to be the tangent of the angle here. So why go through all this stuff? Yeah, it was fun, but you know, it wasn't necessary. You could have gotten this just by going vertical component divided by horizontal component. That is the tangent of the angle. So what would the angle be? The inverse tangent of that. Okay? You got it. Okay? So let's do example 7. So when they say find the direction angle, we're looking for some angle theta. Okay? What's that? Okay, yeah. I think okay. The slide set got one behind earlier in the section. Okay? Maybe one of those many days you were absent or something like that. So, okay. But anyway, they did get one behind. In our text, this is example 8. In the slide set, it's 7. Sorry, I wasn't paying attention. All right, so we want the direction angle theta. So let's do theta for A here. What would that be? How would you do it? You might not want to just write down the answer yet, so let's do it. What would you write down? Based on what we just said. Second?
When you say it's the horizontal divided by
Okay, the tangent of that angle theta that we're interested in is equal to the vertical component 3 over the horizontal component 3. Okay, and what is that? 1. And what would be your angle theta then? 45 degrees or pi force, if you're dealing with radius. Okay, you're in the first quadrant because you're 3 on x and 3 on y, okay? You're in the first quadrant, so that would be your angle 45, okay? How about the B one there? What was the story with that one? Okay, the tangent of your direction angle theta is equal to -4 over 3. Okay, now here you have a problem, Houston, okay, because that's not one of our favorite angles, okay? I don't know what that one is, but what are we going to have to do then to get your angle theta? Yes, the inverse tangent of -4 over 3, okay? But we may still have an angle, a problem, okay? Someone do the math there and tell me what you get. I think I'd prefer the answer in degrees, huh? Okay, theta is equal to -53.7 degrees, is that what you said? Huh, 0.3 degrees? 0.13 degrees, okay. Now, do y'all think that's right? Say again?
It's negative.
Okay, no, but it is right though, okay? Because you're going 3i and -4j, yeah, you're down here. And you're past 45, so yeah, that's perfectly correct, okay? But I was wondering, what if that had been -3i plus 4j? What would your ratio have been then? Plus 3i over minus 3i plus 4j. Say again? What if that would have been your V? Let's not call it V, let's call it something else, like W. W was -3i plus 4j. What would have been your angle then? Start with 10. Start with tan theta. Would be what? Say 4 over -3, which is the same thing, isn't it? Is that the same angle?
Yes.
Your calculator tells you it is. Are you even in the same quadrant? No. Here, you're -3i plus 4j. You're over here. So that can't be -53.13. It can't be. That's down there. What you do, add 180 to it. Because remember, inverse tangent, here's the problem. Inverse tangent is only defined from -pi halves to pi halves. It's not defined over here for obtuse angles that way, either in quadrant 2 or 3. You'll never get an answer. So if you know you're in quadrant 2 rather than quadrant 4, then add 180 to it. And that puts you right up to where you need to be. And if you're in quadrant 3, you wind up with an answer like you did up there, pi force, add 180 to it, and you're down here. So, or 45 degrees. So that's what you have to watch out for. This one worked out perfectly fine. Of course it would. They gave that as an example. I'll wait and give you the others on the test, right? Yeah, no, we wouldn't do that, would we? Okay. So you always have to stop and ask yourself, am I in the right quadrant? If you're not, add 180 to it. Or add pi to it if you're in radians. This one, you worked out just fine. Okay. All right. That was example 8. And the book gave 53.13 degrees. It would be a negative. If you want that as a positive angle, not a negative angle, then you add 360 to it, you know, and that gets you around to come around this way. So either way, there's nothing wrong with negative 53.13 because that's the quadrant you're in, fourth quadrant. So that's fine. Any questions? Okay. In the book, they seem to like to give only positive angles. So if it gave you a negative angle, add 360 to it. If you're in the wrong quadrant, add 180 to it. Okay. Quick rules. Okay, so let's see how they did it. Let me erase my scratch. And the first one was pretty easy. The direction angle is determined from tangent theta is equal to b over a, which is 3 over 3, which is 1. And the inverse tangent of 1 is 45 degrees. 3x, 3y, yeah, you're in the first quadrant, got to be 45. In the b part, get same formula, tangent theta is b over a. That was minus 4 divided by 3. And that would be, because you're in the fourth quadrant, that lies in the fourth quadrant, its reference angle, and boy, they're going through the reference angle now, is the absolute value of the inverse tangent, which gave you, they went to radians. I'm not sure why they gave, and then they went to degrees. I'm not sure why they're doing all this, but they put the absolute value. Actually, that answer without the absolute value is absolutely correct. But they like to give you positive angles, so not that positive angle, that would be in the first quadrant. Boy, did they ever do it weirdly. Then they subtracted that from 360. If you just added 360 to this, that's the same as subtracting this from 360. You would have been right where you belong. So if you have a negative angle and you want it positive, add 360 to it, or 2 pi to it. If you have an angle that seems right, but you're in the wrong quadrant, add 180 to it. That puts you up in the opposite quadrant, and that gives you the correct answer. All right. Let's move on to applications. Now, the strange thing, the book didn't go into any of that, but you have to think through that. Applications. Yeah, this is example 9 in the text, example 8 on the slide set. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 150 miles per hour at an angle 20 degrees below the horizontal. So it says find the component form of the vector that represents the velocity. Okay. Well, the actual velocity they gave, well, at speed, 150 miles per hour this way. Okay. At an angle 20 degrees below the horizontal, as shown here. If they hadn't shown you this, you could have had it over in the fourth quadrant. They showed it here, you're in the third quadrant. Okay, so that means you're, all they're looking for, what are they looking for? Find the component form of the vector that represents that velocity. Okay, so what would that be? They gave you the angle. Well, they told you this, 20 degrees below the horizontal. If you're in this angle, below the horizontal. Horizontal would be 180. Below that, 20 degrees would be 200 degrees. So that gives you your angle. Okay? The rest of it is, I think, quite doable. How do we do that? We want the component form of the vector. They don't name the vector. Do you want to give it a name? I don't care. You don't have to if you don't want to. Okay. What would be the component form? You tell me this. What does that 150 give you? It's the speed of the airplane. What is that in a physics sense? What? That's the magnitude of your velocity vector, right? So if you weren't going to name it a name, just to get it to look like we did in the book, if you named it the vector v, if that's what you're looking for, and you're looking for the v sub x and v sub y, okay? If that's what you're looking for, then you know this 150 is the magnitude of that velocity vector v. I think that's why I was trying to get you to give me a name for it so we can write this down symbolically. Okay? Now, does anyone remember what those components are and how they relate to the other piece of information? 150 is the magnitude. The other piece of information is the direction, 200 degrees. Any relationship? Okay, that's true. But I think what you're calling A, I've been calling V sub X, and what you're calling B, I'm calling V sub Y, right? So we're just giving them different names, okay? If you want to do AB, you could do that. That's fine too, okay? But anyone remember a relationship between the magnitude and the angles and the components of the vector? I know it was a long time ago. It must have been at least 15 or 20 minutes. Okay. Maybe longer. Oh, there it is. It's not close, but not quite. There it is. Right there. A and B are, yeah, I call it V1, V2. A and B is fine. What is the A component? Right there. A is, this is the I, and that's the J. A is magnitude of V, we know it, 150, right? Times the cosine of the angle. We know it, 200 degrees. Plug it in. And that's always the case. Magnitude times cosine is the horizontal component, magnitude times the sine is the vertical component. Always. 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 All right. So what would be your A, if you want to call it A, or V sub X, whatever you want to call it? Okay, certainly the cosine 200 is going to be involved with it. What else are you missing? 150 times the cosine. That's it. That's it. And then the B would be 150 times the sine of 200 degrees. And guess what? If you're using the 200 degrees, your calculator is going to take care of the sines and everything else for you. Be sure you're in degree mode, though. So what would be the component form? What's your A? Anyone do it? Negative 140. Second?
Negative
0.95. Let's call it negative 141, if that's okay with you. Okay. And the B. Negative, right? Huh? Ah.
I got negative 51.3.
51 point what?
0.3.
0.3? Let's call it negative 51. Now, why do I know it's negative? Yeah, third quadrant, folks. It's got to be negative x and negative y. And longer negative x, shorter negative y. That looks pretty good to me. You can check that by doing square root of 141 squared plus 51 squared. I bet you get pretty close to 150. Won't be exact because we rounded a little bit, but it'll be pretty close. Not too hard to do, was it? Okay. Magnitude times the cosine is the x component. Magnitude times the sine is the y component. Many of you, I hope, are moving on to physics at some point, right? Maybe not everybody. You probably won't be because you're graduating, okay? But if ever you do, you're going to be using this all the time in physics, okay? Well, not all the time, a lot of time. Okay, is that what they got in the book too? Oh, we're going to see that, aren't we? Let's see what they, oh, there it is. Look at that. They wrote it down for us. Magnitude of V times cosine theta I plus magnitude of V. Once you determine the angle was 200 degrees, and the magnitude was 150, which they gave you basically, you could just write it down. And that gave you, oh, they really strung it out, didn't they? Negative 141, we said, I minus 51, J. Okay. The only reason I didn't carry 5 digits here and 4 digits there, nothing they had guaranteed us anything beyond 3 digits. So I dropped it, stopped at the decimal point, rounded. And I bet you if you do what we did, 141 squared plus 51 squared, you're not going to come up far off from 150, much further than you would doing these numbers. Maybe a little bit, but not too much different. Okay? Any questions? See how it works? Okay? So written in component notation, negative 141, comma, negative 51. Oh, and here they check it. You can check that it has a magnitude of 150 by plugging those in, and you get that, which comes up approximately equal to 150. Whether you use my round off or their round off, you're going to get pretty close to 150. Okay? Now, they don't do example 10, so let's us do 10. Any questions before we do it? A force of 600 pounds, this sounds like a physics problem, doesn't it? Is required to pull a boat and trailer up a ramp inclined at 15 degrees to the horizontal. Okay? So here's the horizontal. Here's the ramp, 15 degrees. Now no guarantee in fact, I'm way off. That's way too large for 15 degrees. Okay? And the boat and the trailer are going up the ramp. They show the water level here, but who cares that? They're going up the ramp, you know, being pulled up the ramp here by 600 pounds. Force of 600 pounds is required to pull the boat and the trailer up a ramp inclined at 15 degrees from the horizontal. Find the combined weight of the boat and trailer. What? Combined weight of the boat and the trailer? How can you get that from how much it took to pull it up? Well, weight is always straight down. Okay? This is the weight down here. Let's just call it W. Okay? Now, there are two components to that force. There's a horizontal component, well, no. There's a component parallel to the ramp and perpendicular to the ramp. So this is what we're looking for, this W. So we have a component that's parallel to the ramp and a component that's perpendicular to the ramp. Right angle to the ramp. Okay? Now, yeah, I've already got 15 degrees. Now, in this triangle that we just did, okay, here's the weight that we're looking for. There's a parallel component and a vertical component. If it's requiring 600 pounds to pull it up the ramp, that means this parallel component is 600 pounds. Okay? Now, let's get our angles in here. Here's 15 degrees. That makes this angle right here the complement of 15 degrees, which would be
75.
75 degrees. Well, that angle there is the same as this angle here, isn't it? So that's 75 degrees there, which makes the one down here our 15. Right? Now, and this is our 75 degrees up here, because that's 90. Okay? Now, with that in mind, what we're looking for is the hypotenuse here. W is your hypotenuse for that right angle right there. Okay? So we have that 600 is equal to now, just have to sort of rearrange things a little bit here, but isn't that equal to the weight, which is the hypotenuse, times the sine of your 15 degrees? Because the sine of 15 degrees is going to be the opposite over the hypotenuse. And the opposite is your 15, is 600 over this, so that's going to give it to you. So weight is equal to, divide both sides by the sine of 15 degrees, and that will give it to you. So someone punch that in and see what you get. Combined weight of the boat and trailer. I have them below water. They didn't have them in the book. They had the water level down here somewhere, so ignore this water level. Okay. What you got?
2,318.
2,318 pounds. Okay? Does that sound reasonable? How can you pull a 2,318 pound trailer up a ramp with only 600 pounds? It's because the ramp is supporting most of that weight. Okay? See, the normal force, the ramp is supporting most of that weight. You're only supporting the smaller leg of that weight. So sure enough, that seems reasonable. See what they got in the book? Oh my goodness, look at that. 2,318 pounds. Good deal. Approximately. Does that make sense? All right. They also skipped example 11. So let's see if we can do that. I didn't bring my watch in today, so is someone going to watch out for me?
Yeah, like
5
5 minutes.
minutes. Ooh, can we do example 11 in 5 minutes? What you think? Give it a shot? Okay. Frankly, I'm afraid not. Okay, sorry. Let's start there next time. Okay? And let me give you some homework exercises. Otherwise, y'all will be leaving without any homework exercises, and that would be distressful to you. Very distressful. I know. Okay, but let's look a little bit ahead, too. 6.4 is vectors and dot products, which is a very useful and important thing, so we'll get that done hopefully next time, or at least go into that. I don't think we'll get to 6.5, which is the complex plane. Too bad, okay? But we, and then 6.6 is trigonometric form of a complex number. I didn't even realize they had 6 sections here. But anyway, we're not going to get that far. So let me give you homework examples here. Do number 9. It's there for you. You should be able to do that pretty easily. It's a Calc Chat. Do either 11 or 13, they're both at Calc Chat, 11's at Calc View. Do either 15 or 17, they're both at Calc Chat. Then do any of the odds 19 to 23, they're all at Calc Chat, 19's at Calc View. Do any of the odds 25 to 29, they're all at Calc Chat. Do any of the odds 31 to 35, they're all at Calc Chat, 31's at Calc View. Do either 37 or 39, they're both at Calc Chat, 37's at Calc View. Any of the odds 41 to 45, they're all at Calc Chat, 43's at Calc View. Either 47 or 49, both at Calc Chat, 47's at Calc View. Either 51 or 53, they're both at Calc Chat, 51's at Calc View. 57, or any of the odds 55 through 59, they're all at Calc Chat, 57's at Calc View. Either 61 or 63, they're both at Calc Chat, 61's at Calc View. Any of the odds 65 to 69, they're all at Calc Chat, 67's at Calc View. Do 71, it's a Calc Chat. Do 73, it's a Calc Chat. I think you can now do 75, it's a Calc Chat. Let's hold off the ones beyond that. That's more like the one we're going to do next time. And I think that will give pretty much what you need on that one. All right, any questions? Okay. What are you bringing to me on Thursday? Your research paper, if you haven't turned it in already, and all the remaining tests. Does anyone need a remaining test? Test 3? Okay. I wish I knew where Cynthia was, because she was out in the hall when I went down to get my stuff, and then she wasn't when I came back. So I don't know where she is. What's that?
I'm not going to be here on Thursday. I have a game.
Okay. That's it right there. All right. And you need the third test. Is that right?
Can I go ahead and get?
I'm sorry.
Can I go ahead and get my final test?
I may not have it run off yet. Let's see. Are you going to be on Birmingham campus on Friday?
I'll be there tomorrow.
Tomorrow. Okay. Will you be there tomorrow evening between 4:30 and 6:30?
Well, I get out of practice at like 4:30, so I can come up there.
Okay. Okay. Now, where I'm on at 4:30 tomorrow, I'll be on the East Campus. Do you live in the dorms?
No, I stay at home.
Okay.
But the East Campus is where it's on the far side.
Yeah,
like by the White House and all that, right?
The White House.
The White House is just, okay, so when you go over the railroads, right, you turn left and go like you're going to Lawson. The first sign, you see the baseball field on the left, right? You keep going straight to the stop sign, make that left and go all the way on that side. That's what the East Campus is.
Yeah. Do you know where the dorm is? Okay, the dorm is on the East Campus.
Yeah.
Okay, there's a dorm, then there's a new dorm, then there's some sort of house at the public affairs and stuff like that. So then there's the nursing building. You know what I'm talking about there? Right before you get to A.G. Gaston.
Yeah.
Okay, nursing building is right there, just 2 doors down from the new dorm. You know, there's the public relations. Yeah.
I can get, if you're going to, if I don't see you tomorrow, Seth will be here, and can you just give Seth 2 tests? And I'll get
Seth?
Seth.
Seth?
Yeah, is that okay? The one that sits behind me.
Right.
Yeah.
Is he a baseball player?
Well, he was. I just went to high school with him and stuff.
Oh, you did? Okay. All right.
Yeah.
Okay, so give him your...
Yeah, if I don't come tomorrow, because I don't know if I'll get out in time or
Why don't I just give it to him?
Yeah, just give it to
Okay.
him on Thursday.
Is that, okay, because I know I haven't run off then. I don't know they'll be run off tomorrow.
And we just have to have them turned in by next Thursday?
Next Thursday is when they do, but as long as you're not graduating, I can take them as late as the
Okay,
following Monday.
I can try to bring this to you. Like, I think Thursday is a home game, so we'll be done. Are you going to be there on Thursday at Bessemer campus at like later
Birmingham
that night?
campus?
Or yeah, Birmingham campus.
Usually I'm not there. I'm here. See, I have a lab that goes till 5:45 here.
I'll find somebody.
Okay, yeah. Can you give it to Seth?
Yeah, I probably can.
Okay. Yeah, he could turn it in for you then. Okay. Yes.
I was basically asking the same question he was.
I'm sorry. Okay.
Yeah, but Thursday I won't be able to come because I have to take my aunt to surgery. But
Okay.
I'll be able to stop by and turn in my research paper.
Okay.
And
Now, if I'm not in the office, you can slide it on my door. Do you know where my office is? Okay,
isn't it
265.
down the hall?
Huh?
Isn't it downstairs?
Yeah,
down there?
yeah.
Yeah, I think I seen it.
Okay. Now, let's see. So you need your others, your chapter 6 and your final. Okay. When?
I can probably come before class starts, maybe.
Before class on Thursday. Okay. Okay. Now on Thursday I have a class down the hall. I'm not in this room. In 205 from 8:30 until 9:45. So you, is that where you want to come get it? Then?
I can.
Good deal. Thank you.
It's either going to be probably during that class or before this class.
Right. Yeah. Well, that's the thing. Before this class, I'm down there. But oh, you mean just like 15 minutes before
Yeah.
this class? Oh yeah. Well, then I'll be making my way here then. Okay.
So, and then
I'm also here between 8 and 8:30. Are you here that early?
I'm not sure,
Okay.
but I think I just have to turn my test 3 in and my research paper. So can I bring it to you tomorrow?
Oh yeah, absolutely. Yeah, I'll be here all day tomorrow. I've got office hours between 8 and 10 tomorrow. So then I'll be on campus until right around 4 o'clock. At 4 o'clock I have to go there. But even if it's after 4, you can slide it under my door,
So
and
your
I'll pick it up Thursday
So
morning.
your office hours are 8 to 10 in the morning tomorrow.
Tomorrow, right.
Okay, so I think I'll be able to come in the morning because I have to go to work, but I work at that Walmart right there.
Oh, I see.
So I might be able to bring it here before I go to work. Yeah, I go to work at 9:45, so I probably bring that in the morning.
Okay. And if I'm not in the office, just slide it under my door. 265.
And then Thursday, okay.
Yeah.
Gotcha. All
Okay.
right, thank you.
All righty.